So the next topic are combining operators in the mono class. And these are some of my favorite things that we get out of monos. They are really, really, really interesting. So we're going to talk about zipWith, zip, when, and firstWithSignal. And these operators create a mono from multiple monos, typically more than one. And you'll see that they have some really, really interesting semantics. So we'll talk about zipWith first. So what zipWith does is it takes two results and combines them into one result after both of the two previous results emit. Both of the previous monos emit. And the parameters are kind of interesting. You can see here that they have this thing that's called other. And as we'll see, other is the second mono. The first mono is the one that you call this method on, right? So you say like, m1.zipWith m2, right? So you have two monos, m1 and m2. And then we also pass in something we call a combinator. And it's going to be a by function, which, as you can recall, takes two parameters and returns a single result. So this basically returns a mono that emits the combined results. So you can think of it as a logical conjunction. And that should be very familiar to you after doing the completable future assignment, because we had one of those there as well. Just had a different name called then combine. zipWith, like flat map and map and other things, can transform the type or the values of the elements that it processes. And here's a fun, very simple example. We're going to go ahead and create two big fractions asynchronously. So we're going to make big fraction async. We're going to call that twice. We're going to get back two monos to a big fraction. And again, let's assume that they're really big fractions, and therefore they need to be run in the background. So they're running in a background thread to avoid blocking the caller. And then we say m1, which is the first big fraction mono, zip with m2. So that's basically saying, wait until m1 and m2 are done and they emit their results, and then combine them. And we're going to combine them in this case by using the big fraction add method, which is just something that's a by function. It takes two parameters and returns a single result. So it adds the two results of the asynchronously created large random big fractions, and it adds them after the other one's complete. And in this particular case, you can imagine there's really no sense in running that asynchronously because we're just adding two things together. But I guess if they were big enough, we could run them asynchronously, and we could do that by using subscribe on and all the other good stuff to run in the background. There's a zipWith method that's part of RxJava single class that works exactly the same way. And this should look very familiar to you because it's basically what we have with Java completable futures then combine method, which you got a chance to use in your assignment number 3 to be able to take the results of counting the number of images that were on a page, and then taking the number of images that were reachable from that page, and then returning the results of adding those two things together. So that was zipWith. We're now going to talk about a generalization of zipWith called zip. And whenever I see zip, I think of Dr. Evil from Austin Powers. If you've never seen the movie, it won't make any sense, but he keeps saying, zip, zip it, zip it. So that's what zip is doing. It's zipping things. So this is going to take a bunch of monos, represented, as we'll see in a second, by a varargs parameter, and it's going to aggregate them into a new mono after all the monos that are passed as a parameter are done. So this is a really funky method. And it's crazy when you see how it works. I won't give you the full details till we get to the case study walkthrough, but it's really, really interesting. So what it does is it says, we're going to have this variable length parameter called monos, and ... just means there could be, many of them, 0 to infinity. Well, I guess you can't have infinity because it's going to be bounded by the size of the memory, but you could have an array of these things that could be very large. And it's going to basically wait for all of those things to finish, and then it's going to go ahead and apply this combinator function. And this combinator function is completely insanely weird. It takes an array of objects and then something that extends the value, the type R. So you'll see what this thing is when we get a little further along. It's just too weird to even begin to explain. But I'll show you an example that illustrates how it works. This is one of those things where it's actually devilishly hard to find good examples online to show how to use this method. So we will walk through an example to make it much more clear. it returns a mono that emits the combined results. So at a high level, it makes sense. You're taking a bunch of things running asynchronously, and when they all finish, we're going to go ahead and combine them together somehow. And that should sound strangely familiar for reasons we'll talk about in a second. As with the zipWith, zip also can transform the value or the types of the elements that it processes. So here's a very, very simple example, and it's also an incomplete example because I couldn't fit it on one slide, but we'll look at it in more detail here in a moment. So this time we create 3 big randomly generated big fractions asynchronously. So we have M1, M2, M3. All those things are being generated in the background. And then what we say is we're going to say zip M1, M2, M3 together. And when they're all done, combine them and return a mono that is going to emit the combination of all those things. So it's going to basically, in this case, add them all together, as we'll see when we look at the example in more detail. There's a zip array method, once again, not quite named the same, in RxJava's single class that does the same thing. And I guess in some sense, you can sort of think of this a little bit like the all of method that we've got with completable futures. It's kind of like completable futures all of. All right, so now let's shift our attention to operators that work by ending things together, right? You wait until they're all done. And let's go with one that is more like an OR, and that will be something called firstWithSignal. So what this does, and this will also sound familiar to you as well, it's going to pick the first mono to emit any signal, which could be empty completion, error, or a value, and then it replays that signal. So whatever finishes first in a bunch of these things is the one that's actually going to be used and emitted as the result of firstWithSignal. As you can see, it basically takes a varargs parameter, and the method then picks the fastest of these competing mono sources. So basically what it's saying is it's saying a bunch of things have been set in motion. Here's a varargs array of the monos to those things, and when they are, whichever one finishes first, take that result. So you can think of this as basically logical disjunction or ORing. It's saying whichever one finishes first, I'll take that. It's a logical OR. And it's really whichever one is the fastest. Unlike other things you've seen before, where the other, say, completable futures that work like this were able to continue processing, the ones that don't finish first are disposed of. So it's basically like a race where the penalty of not finishing first is you're shut down entirely. It's not the kind of thing you'd want to do in a normal race, but that's the way it works here. So here's a very simple example. You've seen an example like this before. We will look at this example when we get a little further along. This is going to take 2 lists, and it's going to quick sort one list in a background thread out of a parallel thread pool. It's going to heap sort the same list in a background thread out of a thread pool, and we're going to get back monos to lists of these big fractions. So we're basically doing quick sort and heap sort at the same time. And then whichever one, and then we're going to use firstWithSignal, which will say whichever one of those sorts finishes first, take its result, cancel the other one. We're done. So again, this is going to look very familiar to you based on our completable futures discussion, but it's basically selecting the result of whichever sort finishes first. There's a very oddly named method in RxJava's single class called AmbArray, which stands for ambiguous because you don't really know which of the results will finish first, so it's ambiguous which one finishes first. Go figure. And it works the same way. And it's also very similar to the any of method in completable futures. So remember, the zip method was kind of like all of, and the firstWithSignal is kind of like completable future any of. It'll pick the first one, with the difference being any of doesn't cancel the other ones. So the question is, why does the firstWithSignal method cancel its results, whereas any of doesn't? Just because they just did it a different way. I mean, they were, I guess, looking at things from a different design point of view. They really want firstWithSignal to say, whichever one of these things finishes first, just take it and get rid of all the other ones. And for some reason, the any of, I think I've mentioned this before, the reason why any of and all of don't work that way, or the other ones that will, sorry, not all of, any of, and then the, I think it's except, what is it called? Apply to either. There's this thing called apply to either that works the same way in completable futures. They just wanted to be able to keep the other computation running in case someone else was waiting on its result. So just a different design principle, but it's confusing because you have to remember what the semantics are if you start mixing between the two frameworks. So the fourth and final combining operator we're going to talk about in the mono class is the when method. And this is a really interesting method. What it does is it aggregates given publishers together into a new mono. And what's provided here is an array of publisher sources. So it's a var-args array. Again, it could be 0 to whatever the max size of the array is. And it returns a mono to void, and the void will be fulfilled when all the sources have completed. So remember, a mono to a void doesn't actually emit any result because void is the non-result. It's like the anti-result. So it just indicates we're done. It doesn't say, and here's the result. If an error occurs, then it will give an error emission in the returned mono. So there won't be any result that comes back at all. It'll indicate an error that occurred. Now, what the heck would you ever do with this thing? Well, you can use it very much like all of, in the sense that it's used to wait for a fixed but arbitrary number of publishers to complete. So here's a simple example, and this is going to look very familiar because this is basically like the futures collector that we've been talking about. In fact, you could implement a collector with this type of an approach quite nicely, as we'll see. We have a monos collector we'll look at later. And what we do here is we're going to say mono.when, and we pass in a list of, or an array of monos. So we have an array of monos, and that will return a new mono that completes when all the monos in the list have completed. So when everything in the list is done, then that will complete. And then we use this really funky method called materialize, which sounds like transcendental meditation or something like that. You know, we're going to materialize something out of the ethereal world. And whatever happens, whether it's on next, on error, on complete, that's going to emit on complete. So it just says, we're done. That's all it's doing. It's aggregating something and saying, we're done. And then once we're done, what we're going to do then is we're going to flat map this thing. So we're going to go ahead and take that list of monos and then convert it into a list of monos to type T's, convert it into a flux. Then we have map.mono : block, which converts the flux stream of monos to type T to a flux stream of type T's, which we collect into a list. So this is, again, is very much like what the collectors were doing when we talked about that before, and we'll see how to do this later. There is no RxJava equivalent, which is kind of a pain. It's similar to the all of method that's defined in Java completable futures. Works much the same sort of way. It took me a while to figure this out. This is not something that's widely documented. You could look for a long time and not really find many descriptions of how to use when, but once you understand it, it's very powerful and can be used in idiomatic ways similar to other things that you may be familiar with from other reactive programming frameworks like completable futures. Okay, that's the end of the discussion of key combining operators in the mono class. As you can see, it's a lot of very subtle stuff. But if you step back and look at it at a high level, we've got things that do logical conjunction like zip and zipWith, which wait for a bunch of stuff to finish before you do something to the results. And then we also have things like when, which is also kind of like that. It waits for a bunch of things to finish. And then we have the firstWithSignal, which is kind of logical disjunction. It waits for the first of a bunch of things to finish, and then we'll do something in response, or just have it done. So very cool methods, very powerful, reminiscent in a lot of ways to stuff that you find in completable futures for good reason, because these are things you need to do with asynchronous computations to wait for all of something or one of something before you do the next step.